What's up, guys? Today on Dirt Lifestyle, we're going to build a 4-link rear suspension and weld up the rear axle on my 1-ton Land Rover. Today's video is brought to you by Barnes 4-Wheel Drive. If you're in the market for affordable, strong fabrication parts for your next suspension, check out their website, and if you want to save an extra 10%, be sure to use our coupon code DIRTLifestyle at checkout. In the last video, I finished welded my front axle, and we went over the basic problems you run into whenever you're trying to weld two dissimilar parent materials. In this video, I want to stick together all the brackets and tabs onto the rear axle, and then I want to finish weld everything and talk about the basic concepts that are associated with building your own 4-link from scratch. All of these end links, brackets, and tabs are a standard off-the-shelf 4-link kit. This is nothing special. I like universal 4-link kits like this because this could be used on any of these vehicles you see in here. We're going to use it on the Disco, but this could easily be adapted to the J truck or be adapted to my TJ. Now, I upgraded to these Enduro joints because I wanted something that was super beefy, really heavy duty, and rebuildable. So I know that with this giant stud, I'm not going to shear this off on the trail and be stranded. And I also know that a few years down the road, whenever these races start to wear out from all the abuse, I can just order some new races, plop them in there, and I'm good to go. We're also going to be installing a mini truss for this rear axle. If I could have fit a full truss, I definitely would have. But because of how narrow the frame rails are and how narrow we're going to have to make these lower coil buckets, I knew that I wasn't going to be able to fit a full-size truss very easily. But this is going to help keep these rear axle tubes from spinning, which I have seen happen twice on the trail, and both times when I've seen the rear axle tube spin, it was a nightmare scenario. This is going to help keep that from happening, but it's also going to be a really strong upper mount for upper control arms. Watched this channel before, you know that I love a grid. I like to lay out on the floor, I like to make a grid and set things on top of it so I know exactly what it's going to look like, and I just get a lot better perspective as to what needs to be done and where to place brackets. So that's what I've done here. We've got a frame rail on one side here, a frame rail on the other side there, and this is a perfect center line between the frame rails. I took a measurement of the width of this axle and I made a mark on the diff cover for the center of the axle, and with my line laser I'm able to line the center of this axle perfectly in line with where the frame is going to be on the Rover. So if you check it all out, you can see where I've got all these brackets laid out. Everything's tacked into place except for these top two, and that's one of the reasons I wanted to do this. I wanted to take a look and see what kind of angles I'd be looking at with the suspension that I'm considering building. And so I made some different marks as to where the joints are located. This is the center of the joint on the inside of the frame. This is our upper control arm mount. This is the joint that's on the outside of the frame. This is our lower control arm mount. And I just played with some different angles and stuff to see what is and isn't possible and to see what kind of suspension I'm gonna be able to get away with. And now I know exactly how we're gonna build this. Before I finish weld this axle, I went ahead to the whiteboard and we're gonna just talk about the very basics of 4-link design, because I get asked questions about this a lot. And I just wanted to draw it up on the whiteboard. We can talk about some really rudimentary concepts, and hopefully this will help some of you guys that are starting to look into this stuff to build something like this yourselves. So this design right here is what you're going to find in most Jeep Wrangler series that is coil sprung. So leaf sprung, of course, does not apply to this, but anything that's coil sprung, they design it just like this. They have parallel 4 links. So you've got 1, 2, 3, 4 links, and then this 5th link up here is a panhard bar. It's still technically a 4 link. No one calls it a 5 link, but in the real world, you end up with 5 links because these are parallel. It makes it to where it doesn't fight the axle trying to go side to side on you. So you have to put that panhard bar in there, or track bar, in order to keep the axle from going side to side away from the chassis. Now this is, to me, the holy grail of 4-link design, but it's very difficult to package for most people, me included. This is a double triangulated 4-link, and the reason that I like this one so much is that the way the axle flexes and the way the axle is controlled by the upper and lower links, you don't get any flex steer, which is where if the axle is flexing up and down, it will actually rotate a little bit. But with this design, that is not a problem, and you don't have to have a panhard bar. So this is optimal. But usually, you know, if you're a guy with a big V8, you want to run dual exhausts, trying to feed 2 exhaust pipes through there and then get your drive shaft in the mix, things just get so complicated packaging wise. And in front axle applications, this is almost impossible unless it's on a buggy or something like that, because you're going to have an oil pan, you're going to have downpipes, all kinds of stuff that just run right into those upper and lower control arms. What we're going to do today is a semi-triangulated 4-link, and this is just because of packaging. I have drawn this up in so many different ways to try and make this work with what we're building today, but there's no way I can do it. There's not enough room. The way the frame rails are located makes it to where we're super limited on what we can do. So we're going to do a semi-triangulated 4-link. This is still a great design. We won't need a panhard bar, which I love. This is the exact design that I used on the back of my TJ, and it's great. But in extreme scenarios, if you're flexed all the way up or all the way down on one side or the other, you will have a little bit of flex steer. This is extremely overstated. I just want to talk about the fact that I don't even notice it. If you had someone drive my Jeep through a giant pile of rocks, they're not going to be like, wow, man, this thing seems to have a lot of flex steer. It's not super noticeable. In fact, I don't think it's noticeable at all, but it is something that's definitely worth mentioning. So if you're trying to build the ultimate, this is the way to go. But if you don't have the kind of room that you need in order to make this work, the semi-triangulated 4-link is the next best thing. Now here's just a couple really quick pointers of what to keep in mind whenever you're designing your rear suspension. One would be the 25% minimum between the upper and lower links. There's a lot of reasons for this. The big one is strength. The bigger the separation is between this upper and lower link, the harder the harder it is for the axle to tear off the bracket. It's kind of a game of leverage. So 25% minimum of your tire size. So if you have a 40-inch tall tire, 10 inches is the minimum you want between your upper and lower link. We're running a 37, and I measured, we're at like 11 inches, so we're golden. We've got plenty of leverage. We're not going to have any issues ripping off brackets or having any kind of weird suspension characteristics from the differential affecting the links too much. So the other thing would be double the wheel travel. So the amount of wheel travel you're going to have up and down, you need to double that for the length of your control arms. I like to go as long as I possibly can without it being so long that they're weak, because that's the biggest issue, is the longer this lower link is, the easier it is to take a rock, and the rock has a bunch of leverage on it, and it can bend it. So there's a few ways to look at this. Double the wheel travel is a really nice way to have a rule of thumb measurement. I'd say, you know, once you have a link that's more than like 4 feet, you're going to start getting really weak really fast. So just a few different things to take into consideration. This rear suspension design that we're going to do, we are going to have the upper and lower links the same length, at least as close to the same length as we can, because whenever this travels down, we want to make sure this pinion continues to face the pinion of the T-case. Now, if you watched the beginning of the series and you watched the video where we built the front suspension, we wanted the pinion to stay basically level with the ground because it's going to be easier on our steering and a number of other factors. But in the rear axle, I always recommend making your upper link and your lower link about the same length, because it makes it a much easier on your rear U-joint, and it keeps that pinion angle rotating and facing your T-case. This has been cooling down all day. I just took the blanket off and we're all the way down to 134. So I'm very confident in the temperature that we're at to leave this blanket off. Some people let these cool for days. I'm not one of those people. To me, it's more important to let everything cool down at the same rate. So I wrap it up in this blanket and it just kind of gives it a nice insulative bubble to let it all cool down a little bit slower, and then to make sure that as it's cooling, it's all cooling evenly. So that being said, I had a great conversation with Barnes 4-Wheel Drive today, and they made some really good points about welding axle trusses. They don't think that it's necessary for everybody to make all these welds all the way around. A lot of people aren't set up to connect ductile iron, which is what this is, nodular iron, to mild steel. So if you're not set up for it, don't put any stress on yourself to make those connections. I did it because I have the rod, I have a machine that can arc weld, so I'm very confident in the process that I use because of all of the research that I've done in order to make sure that I do it right. But if you're just gonna buy a truss or a mini truss and you just bridge over the center section and you weld it really good and solid here and really good and solid there, you're gonna be fine. I mean, in most instances, these axles don't need much trussing anyways. More or less, this is just a really nice heavy-duty raised mount for your upper control arms. So if you can't make these connections, don't. But if you're like me and you like to experiment, or you're comfortable making those connections, it doesn't hurt to do that either. So I use the right rod, I use the right heat. Now that it's cooled down, I'm gonna finish welding these sections right here. I wanted to wait to weld this because my theory is that when there's a lot of expansion that happens during the pre and post heat of this center section. So it was at 500 plus before I started welding it, so it probably got up way above 600 whenever I was welding on it. And then I did the post heat. I think that amount of expansion is probably quite a bit. And if I had welded this to the mild steel and then that center section cooled down, I'd be worried that it would try to pull on these welds. So I let that cool down. We're below 150, so I'm very confident that it's at a temperature that it's not gonna contract much more than it already has. So now I'm gonna go back, I'm gonna weld and make these connections. All the rest of my brackets are all done. So once I'm finished welding these connections and using a TIG torch to clean these arc welds up a little bit, I'm gonna slide it underneath the disco and we can finally build some links. We have a rear suspension. It is locating the axle. It is just being held up with the jack right now. No more jack stands. So everything is as I think it should be whenever we are gonna be riding down the street. I even use the laser to line everything up and center it perfectly in the chassis. So to go over a couple of things, these upper control arm brackets that are mounted on the frame, I put a nice fat heavy duty plate behind the bracket in order to spread the load a little bit. I don't want to have an issue where I rip those brackets off in the future. So because I welded it to a big heavy duty plate and then welded the heavy duty plate to the frame, it's going to give us a lot more rigidity, and it's just going to make it tougher for us to rip that off because it spreads the load out over like a foot instead of, you know, 5 or 6 inches. Also, there's 3 holes up there in that bracket for a reason. It's for tuning, and that has to do with your anti-squat, anti-dive numbers are why you would have the ability to tune and change the position of your upper and lower control arms. It's typically uppers that everybody plays with. And we're gonna go over that in a future video. I don't wanna try to tackle anti-squat and anti-dive in this video, but trust me, I'm gonna go over all the details with anti-squat and anti-dive. I get asked questions about it all the time. So we do have an issue with clearance back here. For the original Wattslink suspension, we have these brackets that are hanging out back here, and those are both gonna get cut off, and then we're not gonna have any more issues with clearance. Also, I'm gonna have to relocate the sway bar. I definitely want to reuse the factory sway bar, so I'm gonna have to relocate it somewhere, and I just need a little time to think about the best way to do that. But check this out. If we drop this jack, you can kind of see the suspension a little bit better back here. Yep, everything's looking good. You can see the triangulation that we were talking about on paper over there, or on whiteboard rather, and everything looks good. This is exactly how we planned it. I cycled the suspension, and there's no binding. Everything moves very freely, and it's performing exactly as we predicted. The next big step for this axle is going to be paint. Well, actually, we need to locate our shocks, which will be a different video, and then we need to weld our mounts for our sway bar, and then we can move on to paint and install our gears and lockers and all that other stuff. Normally for this Q&A segment, I like to get all cleaned up and whatnot, but I did not have time today. I just went from shooting the last scene, just plopping down. We're going to go through all the Q&A questions that I can in a reasonable amount of time. It's my daughter's first birthday, and I'm going to be taking the whole family to the ocean, so I'm eager to get out there. First question is from Jeep Dude J. How are you keeping the housing from warping with all the welding? I'm using the basic techniques that everyone talks about. Short welds, you know, being choosy as to where you weld. I think that if you're welding a truss, it's important to weld from like the inside out, if you can. It's a tough question to answer. You know, I think that you're dealing with a lot of heat whenever you heat up that center section and whatnot, and there is a chance that if you get it super hot, you weld to it, and then it shrinks down, it could pull. I don't think that it would pull enough to warp the housing, though. That's why I was willing to take the risk. I think that if I got any sort of a significant pull, it would just pull away from the casting. So the long answer is experience. I have a lot of experience welding these axles. I have warped axles. Well, I've warped an axle, and I know exactly what I did and how I had to straighten it and everything else. And the big issue that I have had is welding across the axle for too long of a span. If you notice, all the trusses that I build now, they all have holes that are like half cut off in the bottom, so where the truss connects to the axle, it's like, you know, 1.5 inch welds tops, and then there's a big space, and then an 1.5 inch weld and a big space. I wouldn't do like a continuous weld all the way throughout because it warps axles. If I still had the alignment bar, I probably would have had the alignment bar in the front whenever I was welding everything up, but the alignment bar still only gives you a certain amount of resistance. The key is, I think, welding from the inside out if you can, and then using shorter welds whenever you're welding across the axle. If you're going around the axle, you get away with like a little bit longer weld, but I still wouldn't do, like if you have a bracket that goes over the top and you can weld from center line to center line, I would break that up into 2 welds if you can. Next question is from Dylan Nelson. Is welding the tubes necessary if you have a good truss? I don't think so. I think that if you have a good truss, it's probably not necessary to weld all the way around the tubes. The reason I did it on this front axle is because if you watch the first episode, well, I guess it's not the first episode, it's pre this series. It's whenever I built that front center section and I chopped it from being a driver's side to make it a passenger side, I cut some really big chunks of cast off. And I mean, it's impossible to make a cut like that without gouging into the tube a little bit. So I had some cuts around that tube that I wanted to fill with weld, and it just seemed like a good opportunity to experiment with different material types and alloys anyway. So that's why I did it in this instance. But I think there's a lot of instances where it's not necessary. And if you notice on the Sterling, I didn't weld around the tubes. I only welded the tubes to the truss, and then the truss to the center section. The next question is from In Jeeping We Trust. I hope you address the TIG rod cracking in the next video. I had mixed results when I used it on my build. I did fold the rod over so it was twice as thick so I could feed more rod into the puddle. Looking forward to your solution. FYI, I used stick weld for 95% of my build. It was just easier and looked and felt stronger. I think that is love your stuff, always good, as I believe what you meant there, not love you. Either way, I appreciate the sentiment. After when the cameras were off and I wanted to clean up those welds, those arc welds on that front axle, I was experimenting with that easy weld rod, and even capping an arc weld, it would crack. And I preheated it and everything. I think it's too hard for mixing in like dissimilar metals, I guess. That's my theory. I think that if you used it for something else, like if you used it just to repair a piece of cast where it's not two different materials you're trying to marry together, maybe it would be better in that scenario, but I did not have good luck with it. So in this build, what I did is I went to the welding supply and I got some stainless TIG rod. I've been hearing for years that it works really good on cast. I've always thought that it'd be too hard for cast, but I just used it basically to make a cap over my arc welds. So the arc welds all looked great. I just cleaned it up a little bit with a TIG torch and would just feed just a little bit of stainless rod on top of it, and it made them way better looking. So I'm much more proud of the job now that it looks a little bit better with that stainless rod, and I don't think that I will be using that easy weld rod in the future. I'm not knocking that company at all. I just want to be super clear. For this purpose of marrying these two different materials, I think that it just didn't work good for my application. So for whatever application they intended it for, it probably works great. I'm not going to be using it in the future. The next question is from George EADS. EADS? I'm sorry, man. I know for sure that I'm butchering that one. Wouldn't the heat damage the seals and bearings? Yes. If you have an axle that is loaded with seals and bearings, I've got no bearings in here, but I do have two inner axle seals that I'm going to replace, so I wasn't worried about it. So all of that stuff is going to be brand new whenever I go back through this. But if you have an axle where it has your locker, your all the bells and whistles inside the tubes, I would not heat it up to 500 plus degrees and start welding on it. But if you just need to add like a shock bracket, don't sweat it. Definitely, I would weld onto something that's loaded with all the goodies inside. But I wouldn't cook the thing to preheat the center section and weld a whole truss on there without disassembling the entire axle. Last question of the day is from Adam Strickler. I've only got MIG. Any tips/tricks for MIG welding onto the center section, or should I just wait until I get arc? So if you get the right wire, you can absolutely weld onto the center section. If you get something that's a high nickel content, which I know is available because I have seen it, you can definitely do the same things that I was doing today. I mean, I would prefer to use it because I'm such a big fan of MIG. It's just so much easier, and I have just a billion hours on a MIG gun. But there are downsides. That MIG wire is crazy expensive, and it's really soft. I don't know if I would recommend welding with it in a full-size machine. I would talk to a welding supply before you order a spool of this, because usually it's going to come in a small spool, like a two pounder, and it might be too soft to use in a normal machine. You might need to talk to someone who has used it to find out if it is in fact too soft. Because this is the reason they make spool guns. They make a spool gun so you can put a small 2-pound spool of something that's really soft or really like small and diameter, and it won't kink going through the machine. And if the wire's soft enough, you might have issues where it's just going to constantly get bound up in the hose to get to the gun. So I would do a little more research on that, but if you're determined, you can definitely figure out a way to weld this with a MIG as long as you're using the right wire. If you learned something from this video or you just enjoyed it, make sure you hit the like button, subscribe to the channel if you haven't already. I've got tons of how-to on here, multiple projects. This disco is just the tip of the iceberg. If you want to help support the channel, you can go to thedirtlifestyle.com. We have t-shirts, we have neck gaiters, we got these brand new neck gaiters. These things are awesome. It says Dirt Lifestyle all over it. The color is going to look goofy because of the light that I'm using, but it's black it's gray lettering with black background. It's just, I think it looks stealth. That's what we called it. We called it our stealth design. So if you want to help support us and you need a neck gaiter, head over to thedirtlifestyle.com. We also have a Patreon account there if you want to help support us in that way as well. If you want to follow me on social media, I'm at Dirt Lifestyle Nate. We'll see you next time.